Hi folks, Mr. Long here. We're going to do a screencast on how to graph reciprocal or division functions. And there's some fairly sophisticated thinking that goes into this. Procedurally, it's not a really complex thing, but conceptually it is challenging. So let's look at what the original graph for the division function or the 1 over x function looks like. So there's y equals 1 over x. So we know we've learned all about the asymptotes and why there's asymptotes in class. I just want to reinforce that if I have this function 1 over x and I replace x with 1, 1 over 1 is 1. So there's an ordered pair in this graph at 1 comma 1. So what happens when I do a vertical reflection? Okay, a vertical reflection. Well, if I do a vertical reflection, that y value, okay, that y value right here becomes negative. Okay, so we see the graph is vertically reflected. So where all of these were once positive, they are now all negative. Similarly, where all of these y values were once negative, they now become positive. Okay, so now let's look at a horizontal reflection. What would happen if in the original function all the x values became negative, right? F at negative x. Well, that would mean that I'm going to have to erase this because it's not so different from this. But what would happen here is we would still have this point at 1 comma 1. Remember, this is the original function. And so what we're doing is we're taking all of these values and now we're going to make them negative. So all of those all of the x values rather, because we're doing a horizontal, all the x values there are positive. Now I want to make the x values negative, maintaining the sign of the y values. So you can see it's going to be a horizontal reflection. Will come over to there. Similarly, though, this part of the graph here, all of the x values are negative. In a horizontal reflection, they're all going to become positive. Okay, but what's interesting in the 1 over x graph, look at that. The horizontal and vertical reflections look exactly the same. Okay, the horizontal and vertical reflections look exactly the same. Now, what happens if I do both a horizontal and then a vertical reflection? Well, I think it's fairly obvious that if you start with this, okay, so if we had a vertical reflection here, this is what we get with a vertical reflection. Now what I want to do is, for example, to take this and make now because this is vertical, and then we would do horizontal. Well, that would go over to there, and this part right here would go over to here, and it would look exactly like the original function again. Okay, exactly like the original function. Okay, so we can use this just as a rough idea of how things will look. Okay, let's go through and do an example here. Let's sketch one example. So the first thing we're going to do is to graph the straight line that's at the heart of this, and that's something that we always try to do, right? So for this one here, we're going to graph the straight line x plus 4. What does x plus 4 look like? Well, I know that the y-intercept is plus 4, and if x plus 4 equals 0, if I think of it in a bracket, the x-intercept would be negative 4. And it is sloping up. Okay, so we've got that. So what does that mean? Well, that means that when x equals negative 4, we get division by 0. Okay, we get division by 0. And we can see that just from looking at this. Are we allowed to divide by 0? Absolutely not. Whoops. Wrong location for those, isn't it? So dot at x equals 4, that's called a vertical asymptote. And that's the first thing that you want to figure out, okay? A vertical asymptote. That's your first step. So in this case, we're going to say the VA is at x equals negative 4. Now what I'm supposed to do is to get the behavior when I'm really close to x equals negative 4 on the positive side. Okay, so now what I'm doing is, this is the hardest part, I think, is I'm taking negative 2 and I'm dividing by x plus 4. Well, if I'm just on the right side of x plus 4, then of x equals negative 4 rather, that value is small and positive. So I'm taking negative 2 and I'm dividing by a really small positive. Well, a really small positive will go into negative 2 a very large negative number of times. So this one here, it reflects vertically. Okay, it's going to reflect vertically. So that's going to be right there. Similarly, now at this point, really, I know what it looks like. It's going to look like that, right? That's the way it will have to look. Let's see if we're right. So if I took, for example, this value here, that's big and positive. So x plus 4 at that x value is worth a big positive. Negative 2 divided by a really big positive is, like negative 2 divided by a billion, is almost 0. But it's on the negative side of 0. Which in fact, this graph is, because that's 0 there. So this is down here on the negative side of 0. So we have a vertical asymptote at x equals 4. Now, what we can say is, as x approaches negative 4 on the positive side, okay, so as we get very, very close, so if you look at the graph, I'm getting closer and closer to negative 4 from the right side. That's the positive side. The y value gets down further and further and further, and in fact approaches negative infinity. Okay, that's describing the behavior near the asymptote. And this is exactly how we'll describe behavior in grade 12. Okay, next thing. We've got, this is the vertical asymptote. We've just done that. Now we want to look at, so if you look, sorry, let's go over this. We just did all the transformations involved right here. Okay, we had a vertical reflection because of that negative, and the x plus 4 gave it the sense that it was shifted to the left by 4. So now the only thing we need to do is to add q. Okay, and what's our q value here? 7. So we can see that the y value has plus 7 once I've done this. So we've done this part here is done here. Now I just need to add 7. So what is that going to do? It's going to lift up that horizontal asymptote there at y equals 0 up by 7. Okay, so this is the part where I refer to it as the skeleton graph. So there is the original axes, x equals negative 4, and then I draw an asymptote at y equals 7. Now I can tell from the graph in the previous step that in fact the graph is below the horizontal asymptote on the right side. Okay, so what will that look like? Well, instead of just coming along below y equals 0, now it's going to do this. Okay, so we're going to see it going like that, and then it's going to go like so. Okay, so it's below. So now what we're going to do in one of the final things here is to check and see, did we do this correctly? So as I approach positive infinity for x, that means I'm going to go as far as I can to the right. Okay, a huge number. So what's my equation? Negative 2 divided by infinity plus 4 plus 7. Well, how big is that? That is, infinity plus 4 is like 1,000,000,004. So if you take negative 2 and you divide by 1,000,000,004, that's going to be an extremely small number. And it will, in fact, be negative. Okay, so we're going to be 0 on the negative side plus this 7. Well, where does that leave me? Just above 7 or just below 7? Well, just below 7. So that's going to be 7 on the negative side. So here's what that tells me. This is the part that you really have to pay attention to. That tells me when x gets really, really big, y is going to be just below 7. I now need to go up to my graph. There's the asymptote, the horizontal asymptote at y equals 7. Is the graph just below? Yes, it is. So this process here is verification that our transformation was right. Okay, so something I should have done here, though, of course, is stated that the horizontal asymptote is at y equals 7. Okay, that's the value of q. Okay, and then if I do domain and range, I can define it as the x and y values that we're not allowed to have. So for the domain, I'm never allowed to have an x value that's negative 4. Why not? Because I can't have an x value of negative 4 because that would cause division by 0. Now, the range value, it looks as though I can't have a value that's 7. Why is that? Well, if we look at our equation, look at that equation. So I'm going to put a highlighter around this part. If you notice, that part can never be worth 0, right? There's no way to get 0 there. That's always going to be worth something, even if it's something really, really small. Because negative 2 divided by something is always going to have some value. So this is some value, positive or negative, plus 7. Well, if I have something positive or negative plus 7 that's never 0, my answer to that can be not be 0, be 7, right? Because I'm always adding a negative or a positive to 7. A negative number or a positive number, never 0. Okay, so that's what that means. So we've got our domain, we've got our range, and we've done a sketch. All right, folks, so what you might want to do, make sure when you do this, you read over the instructions very carefully and work through this process. The answers are provided, and it shows you like the vertical asymptote, the horizontal asymptote, and it shows you the behavior as you get close to the vertical asymptote, and then as x becomes huge, a huge positive. Okay, so good luck.